how do we use a software called Orange to help us to analyze the AMIS data set, all right, AMIS house data set. And this is what we are going to build. So eventually what we are going to do is you are going to build a predictive model to predict and forecast the property price based on different features. So maybe I'll quickly open the data set there. AMIS. So this is the AMIS house data set CSV file. CSV stands for comma separated values, and you can see that we have a lot of different features here. There are about 80 features, 80 columns here, and then it covers like the zoning, the types of the alley, the shapes of the lot, utilities, the neighborhood, the condition of the house, and then building type, the style of the house, overall quality. And in terms of the data, there are a lot of different data from discrete numbers, and then we have ordinal values, we have nominal values, and I'm sure that there are some Boolean values somewhere as well. Yeah, there's some okay, there are some Boolean values here, which is binary value, whether there's a basement full bath, basement half bath, and then all the way to the end. Then we have a continuous number, which is our sales price. So the purpose of this exercise is that we need to build a model. Okay, we need to build a predictive model to help us to forecast and predict the house price based on the features. So what you're going to do is you're going to use a software called Orange. You can get this software here, yeah, Orange Lab. And so just download and install. And during the installation, you might need to you ask you whether you want to install a software called Miniconda as well. So I'll give you a brief introduction about Miniconda. Miniconda is a smaller version of Anaconda, which is a data science package data science package which contains software like Orange, Python, Jupyter Notebook, and many other related data science tools, and it helps us to manage our packages as well. So so just need to install Miniconda. And once you have successfully installed Orange, this is what you're going to see. This is your workspace. Now you can see that this is a workflow component based data science, data mining tool. So on your left hand side, there are 5 different panels. You have data, you have visualizations, you have model, you have evaluate, and you have unsupervised. So this maps to the different tasks that we are going to do. For example, in data panel, we have CSV file import, we have SQL tables that allow us to connect to different data sets, different types of data sources, and then you have outliers, you have missing values treatment, you can also transpose the data, you can also calculate the correlations, for example. So what we're going to do is we're going to look drag and drop the CSV file import, and then we're going to import our amishouse.csv. So maybe I'll give you the URL to amishouse.csv as well. So you can download from the link given there. And then once you have, you can look at the import options. Basically, it allows us to define the row as in the type of the columns, the features, and then we just select it. Okay. All right. So that's our very first step. So once you have gotten a CSV file, you can always connect. Link it up with a data table. All right, during it's just like a workflow, so you can connect your components with another component. So if I want to visualize the data, I just need to connect to a data table, double click, and I can view the data inside here. And another thing that I want to show you that's very cool about Orange is distribution. A lot of time when we're exploring our data set, we actually need to see the distributions of different features to get to visualize the trends, to visualize the patterns, and also identify if there's any outliers or any like I would say weird patterns. Okay, some abnormal or not ordinary kind of observation. So you can go to visualize, drag and drop distribution, and connect it to our data set. Double click it. Yeah, and this is a very handy tool that allow us to visualize different columns, different features. For example, I want to know the distribution of sales price, right? This is our main business question. So I can click on sales price and look at it. It seems like it's pretty normal. Yeah, it follows a normal distributions and a little bit skewed to the left. And you can also highlight any of the bar or the columns to look at the data value. Yeah, to look at the value and understand the distribution and percentage. There is also you can drag and drop and change the bin size if you want. Drag the slider, not drag and drop. Now you can also split the columns, further split the columns by using another column. So for example, if let's say I want to know the sales price composition according to their zoning. Yeah, so it will show you that the zoning distributions according at different price point. So I can also look at the say neighborhood, different types of neighborhood versus different types of zoning. So this is a very handy tool for us to explore our data. Okay, and the next thing that we are going to do is we're going to build our model. So before we are able to build our model, we need to select the row. We need to tell Orange what are the tools that what are the columns that we need, what is our input and what is our output. So if you put it into a very basic mathematics form, right, it's like y equals to mx plus c. So you need to select what is your y and then what are your input x. So drag and drop this component called select columns, link it up with your CSV data, and going to select columns, right? This should be what you are seeing. Yeah, there are a lot of features here. So we need to tell Orange that what we need. Yeah, what we need. We need to deselect all of this first. We want to use let's say if I want to select let me think which one is a good one. Let's say if I want the zoning, all right, as my input, and then neighborhood as my input, and also utilities. So some of the things that I think it will affect the property price, and then I can go to overall quality, overall conditions, and also year built. And from here, we have selected 6 columns as our input, right? And we need to tell Orange that what is our output, what is the value that you are trying to forecast, you're trying to predict. So in our case, which is sales price, so we under select columns, we have selected 6 input features and then 1 sales price as our output or target variable. Close this. What you need to do next is to build a model. Yeah, we need to build a model. And for forecasting, if we want to predict a value, the model that we need to use is called linear regression. So come down to the model section and then select linear regressions. Okay, select linear regression and link it up with our select column. Okay, no error. And the next thing that we are going to do is we need to check whether our models is working or not. So we need to evaluate our model, right? You want to know how well our model perform. So go to evaluate and then select test and score. So test and score requires 2 input. The first input that you need, right? Yeah, if you mouse over, the first input that we need is actually the columns, meaning that your input data and also your output variable. So we link it up with our select columns as our input. And then it will need a model. They need to know what is the input data and what model we want to test and check. So in our case, we want to check against linear regression. So we can drag and drop this learner, all right, our model to test and score. Okay, so double click here. And once you double click, you can see that this is the evaluation results. So this is the model, our model linear regressions. MSE mean square error, RMSE root mean square error. I'm not going into the details of different valuation mechanisms here, different valuation metrics, but you need to know RMSE is the one that we usually use. So you look at the error, so it is an indicator about how bad or how good our model perform. In order to look at how well it fits, right, how well our data points fits on our curve, we actually need to look at R2, which is the R square. This is called the coefficients of determination. Yeah, you can look at the tooltip here, square error, mean square error. The R square is a value from negative certain values. Okay, there's basically there's no limit lah, yeah, negative side, but on the positive end, the highest R score that you can get is 1. Yeah, R square you can get is 1. So the closer to 1 the better, but you also need to be careful, don't overfit your model. So in this case, I would say 0.7, 0.8, somewhere around here is good enough for our test, our use case here, because property prices fluctuate a lot, so you can't really get a very good fit. If you really get a very good fit, that means chances are your models overfitted. Yeah. Okay, and the downside of overfitting is that when you take your model to production, it wouldn't be able to perform. Yeah, you will have a huge error range when you put it into production. So you can also connect the data table to test and score. You don't really need to. Yeah, you can just double click test and score to see the results. Oh no, you need to. Okay, so you need to connect data table to test and score to look at the prediction and also the actual sales price. So the actual sales price is 68,500, and our model predicted 77,567. So you can see the error range, the difference between these two. And also you can find that in some property it works very well, some features, some of our input features. In some cases, like for example this one, 178,000 versus 174,000, the difference is only 4,000. Yeah, for the 170, close to $180,000 property. So this is pretty accurate for this type of property. And another thing that you can check is link the data table to your linear regression model, so that you can check the coefficients of different values of different input features. So you can see that overall quality has coefficients positive 32,479, and some of the coefficient has a negative value. So this all play a role in calculating your model, and you know that some you will affect the price, increase the value, or some will affect the price by decreasing the value, and this is your intercept. Yeah, y equals to mx plus c. This is your intercept. So at this point, you have built a very simple linear regression model that help us to predict house price or property price. And what you can do next is to improve the models by tweaking the features, adding more features, or remove some of the features that are not related. Now, of course, in practice, there are a lot of things that you need to consider. For example, when you're using linear regression, they really those variables are independent, and also we need to do some sort of feature engineering, clean up the data, removing null values, etc. But under the data set that we have given, and in these settings and circumstance, I think the model works pretty well. Okay, and let's go back to our PowerPoint. Right, so what we have done here is, as usual, right, all data science projects, all data science demo I gave, we will have 3 parts. The first one is ingredients. So what you need, it's just like a cooking show. You will need data set, because without data set you can't do anything. And then second thing that you need is a recipe. So in our case, the recipe here is linear regression. Linear regression help us to forecast future value. If you need to make predictions, you need to perform classification, then you can use other tools, other models like k nearest neighbor, decision tree, logistic regression, etc. Linear regression is obviously not the most sophisticated or the best model out there, but it's a fundamental regression models for a lot of the other models. So it's good to always start from somewhere that's easy to understand, easy to explain, and easy to implement. And last but not least, you need some sort of utensils, right? Your cooking utensils, and in this case will be orange.